Prabhas. I am going to explain about my assignment. My assignment uh, topic is validation of logical operators. My teammates are Sanjay, Chetan, and Sachin P. Contents are introduction, problem statement, objective, level 1, foundation task, level 2, development, level 3, advanced task, Python code, simple output, and conclusion. Introduction. Automata theory plays an important role in compiler design and programming language processing. It provides methods to recognize patterns and validate expressions using finite automata and context-free grammar. Local expressions are widely used in programming language for designing, making, design, decision making, and conclusion statement. A lyrical analyzer is responsible for identification taken such as logical operators, identifiers, keywords, and determines for from the source problem. Next also. Statement validation of local operator expression design and implement parser that verify whether local expression containing operators such as and or and not are syntaxically correct according to the grammar rules of the mini ATC language, and system should recognize local operators, identify valid identifier and expression, program syntax using context-free grammar.
Objectives to understand the concept of automata theory and parsing, to implement a lexical analyzer for logical expression, to recognizing logical operators such as and, or, and not, to validate the syntax of logical expression using CFG rule, to identify valid and invalid logical expression in a mini ATC language, to apply compiler design concept practically. Levels of implementation of the project. Level 1 foundation task identifier. It identify the finite automata model to check valid identifier. Yeah. Levels of implementation of the project. Level 1 foundation task. It identify the finite automata model to check valid identifier. Identifier must starts with an alphabet and may contains letters or digits. Example: A valid A value 1 is invalid. Level 2 develop.
Level 2 development task. Lexical analyzer for logical expression implemented a lexical analyzer to recognize keywords, identifiers, logical operators, delimiters, logical operators, and or not, and implementation use token scanning and pattern matching generated tokens for each logical expression. Example: A and B, not X, X or Y. Task. Parser of logical operator expressions. implemented a parser to validate logical expressions using CFG rules. Example grammar, expression and expression. Expression gives us to expression or expression. Expression gives rise to not expression. Expression gives rise to identifier. Implementation tokens are generated using lexical analysis, parser checks, correct operator placement, veiled identifiers, proper expression structure, display whether the expression is veiled or inveiled. Scroll.
Here we are using the Python code. The Python program stores logical operators in the list, splits the expression into tokens, uses regular expressions to valid in identifier, prints tokens type identifier, logical operator, display whether the expression is syntactically right. Example A and B, output ident output identifier A, logical operator and identifier B. Expression is syntactically correct. Conclusion: the project successfully demonstrates DFA concepts, lexical analysis, parsing, context-free grammar validation. It shows how compiler analyze the validation logical expression in programming language. Thank you.